So we're continuing our way through the section on solving exponential equations. We're going to look at a few more examples here. So let's go ahead and start. Solve 2 plus 4 to the x plus 1 equals 76. So we're going to apply our method 2 once again, where we isolate an exponential expression and then take ln of both sides. Here, to the exponential expression I'd like to isolate is the 4 to the x plus 1. So I'm going to subtract 2 from both sides of this equation, and I'll have 4 to the x plus 1 equals 74. Now I'm to the point where I can take ln of both sides, so I'll take ln of 4 to the x plus 1 equals ln of 74. And I now am going to apply the third law of exponents and bring the exponent out in front. Now, this is the first example we've seen where we have a slightly more complicated exponent that we're dealing with here. It's the x plus 1 that I have to bring out in front. And what you got to know to do is we need to write x plus 1 in parentheses times ln of 4 equals ln of 74. This is crucial to realize because it's that whole quantity that's getting multiplied by ln of 4. Now we are ready to solve for x here. You got a choice. You got a fork in the road, and you can take it either way. You could distribute the ln of 4 through parentheses to remove parentheses, or you could begin by dividing both sides by ln of 4. I think I'm going to divide both sides by ln of 4 here. And so I end up with just x plus 1 in parentheses. I don't need to write the parentheses since it's all by itself on one side of the equation now, equals ln of 74 over ln of 4. Just a reminder that ln of 74 over ln of 4 can't be simplified using the laws of logarithms. And maybe that wouldn't even occur to you, but I just want to point that out because you got to realize that this does not match up with one of our situations where we can simplify. Also, maybe here's a good point to talk about things sometimes people are tempted to do. Sometimes people are tempted to cross out ln, like doesn't ln cancel above and below? And ln of 74 over ln of 4, if you're tempted to just cross out the ln and say 74 over 4, that's crazy. That's really crazy. No way. Can't do that. Because ln's not a number. Ln's not a variable. ln is tied to the numbers that follow. In fact, there's not really a 74 and a 4 there anymore. ln of 74 stands for this other decimal. ln of 4 stands for this other decimal. You can't take that away. So there's no way to cancel the ln symbol by itself. It's tied to the number that follows. To solve for x here, now I got to subtract 1 from both sides. So I would write this as x equals ln of 74 over ln of 4 minus 1, and that's my answer. It's a perfectly okay way to write the exact mathematical answer. Really can't be simplified much more than that. There are other ways it could be written, but this is fine. And now I'm going to work on my decimal approximation. So 74 ln, I have my calculator here. So x is approximately 4.3041. ln of 4 is 1.3863. And I got to remember when I divide those, afterward I still have to subtract 1 to get my x value, right? So I'm going to take 4.3041 divided by 1.3863. Subtract 1, and I get 2.1047. Okay, and we're through with that one. Let's see if we can do another example on this same video segment. Leave that up there just for a second. Now we're gonna try a really tough one, tougher than the ones we've seen. Let's see if we can solve this number 4 of this type. 2 to the 2x minus 1 equals 3 to the x plus 1. Solve for x. What in a way, you'd say, well, why is this one so much harder? Because it looks like we've already got our exponential expressions isolated on each side. In a way, that's good news. What makes it a little more complicated here is we have the variable on both sides of the equation. So we're going to have to do some rearranging of terms along the way to solve for x, because to solve for x, we're going to need x in one location only along the way. So here, though, we have the exponentials isolated, so let's go ahead and take ln of both sides. And now I can apply the third law. I'm going to bring the 2x minus 1 in front as a factor, and it's got to go in parentheses, times ln of 2 equals, I'm going to bring the x plus 1 in front as a factor, again in parentheses because it's that whole quantity, times ln of 3. And now here's where I got some work to do, because I got x's all over the place. To me, it doesn't make sense here to just divide by ln of 2 or ln of 3, because I got x's on both sides. I really want to remove the parentheses. I want to distribute through the parentheses on this side. I'm also going to distribute through this parentheses. You could write the ln of 2 in front of parentheses if you want to distribute to the right. Same thing with ln of 3. There's no reason these have to be written behind the parentheses that they're being distributed through. And another thing you could do, if the ln notation just like is totally freaking you out at this point, you could go ahead and find a decimal for ln of 2 and replace ln of 2 with a decimal. Same thing with ln of 3. You could just replace that with a decimal. Those are just certain numbers. And in fact, try to see that as like a block, a glued together quantity. It's not really a 2. It's ln of 2 right here, some decimal. It's not really a 3 at this point. It's ln of 3, some other decimal. Now I'm going to work with the ln symbols, but if working with them seems just unbearable, you could go ahead and replace them with decimal approximations at this point. So if I distribute now, I have 2x times ln of 2. I'm going to write that not as 2x ln of 2. I want to keep x behind, so I'm going to write that as 2 ln of 2 times x. And maybe just putting a parenthesis there helps you see that this 2 is inside this ln expression, and it's times this 2 in front before we would even think of multiplying by x. And then minus, I'm going to have ln of 2 times 1 is just ln of 2 equals ln of 3 times x, ln of 3 times x. I'll put the ln of 3 in parentheses in front. That's the coefficient of x, but the ln goes with the 3, plus ln of 3. Okay. And it's kind of like I have two x terms and two constant terms here. These are the x terms. I need to get those on the same side of the equation. The other terms I need to get on the other side. So I'm going to have to add ln of 2 to both sides. And maybe I'll just do that in one step here instead of doing too much at once. So these guys are gone. I have 2 ln of 2x equals ln of 3x plus ln of 3 plus ln of 2. So I actually have 3 terms on the right-hand side now. And again, I want the x terms on the same side. I want this guy over there. So I want to subtract ln of 3x from both sides. So I'm not dividing here. Okay, sorry, I wrote those lines. It looks like division. I'm just going to subtract, so this minus this is gone. The right-hand side becomes a little simpler now, ln of 3 plus ln of 2. The left-hand side is 2 ln of 2x minus ln of 3x. So I have those x terms on the same side. I'm now going to factor out an x. It's like combining those terms into one. I'm factoring out the x so that I can write this with x occurring just once. 2 ln of 2 minus ln of 3. I don't need the extra parentheses at this point. I have 2 ln of 2 minus ln of 3, all in parentheses times x, equals ln of 3 plus ln of 2. Now to solve, I'm going to divide both sides by what's inside parentheses. So we're almost there. Recopy. And I'm going to divide by 2 ln of 2 minus ln of 3 equals ln of 3 plus ln of 2. I'm going to divide by 2 ln of 2 minus ln of 3. This will cancel, and I have x equals ln of 3 plus ln of 2 over 2 times ln of 2 minus ln of 3. And there's my exact mathematical answer. Got it. Now there are some ways this answer could be rewritten using laws of exponents here, but we're not going to do it. I'd say just stop at this point, and we need a decimal form for this answer, correct? So what I'm going to have to do is I'm going to have to plug in decimals for ln of 3 and ln of 2. ln of 3 is about 1.0986. ln of 2 is about, to hit the ln button, 0.6931. I think we saw that before, no problem. So now I'm going to write the decimal. I'm going to add those two decimals together in the numerator. I'm going to take 2 times the decimal for ln of 2 and subtract ln of 3. Maybe I'll write that down. I got 1.0986 plus 0.6931 over 2 times 0.6931 minus 1.0986. So it's that mess of calculator calculation that I got 6.2283 when I round off my result. Here's my decimal approximation for this problem. So let's just get as much on here as we can. Maybe I'll even zoom out a bit to get the whole thing on the screen. That's a tough one, okay? And we're going to stop this video, and we're still going to do a few more examples in future videos.